Hi everyone, I'm Joe.
I'm Ethan.
And I'm Brandon. The video we watched to review the lecture was Cosmology and Exoplanets, unpacking the 2019 Nobel Prize in Physics. Uh, the Nobel Prize in 2019 was awarded to two different parties. The first one was James Peebles for theoretical discoveries in physics cosmology, and the second was Michel Mayor and Didier Queloz for the discovery of an exoplanet orbiting a solar-type star in 1995. Um, the video lecture we watched was split into two topics. The first was cosmology, a study of the universe as a whole, and the second speaker spoke on exoplanets and how we've been detecting them for the past few decades and potential life beyond Earth. So, Joseph, you want to go ahead?
Right. Um, so James Peebles was recognized for theoretical discoveries in physical cosmology. His award was for a lifetime of discoveries that included 40 years worth of published work. Peebles is now widely known as one of the fathers of physical cosmology. A number of his discoveries were highlighted in the video, including that of early nucleosynthesis.
So nucleosynthesis, which that came out in 1966, Peebles predicted that helium would form hydrogen after the Big Bang, and then he predicted the formation of galaxies and how calculated how small density fluctuations would lead to galaxies forming. And he also explained how galaxies get their spin, and co-predicted with another Russian scientist, um, the cosmic web, which is the structure of interconnected galaxies, and how there are high density points versus like vacuous areas where there is basically an absence of galaxies in space. And that prediction was actually confirmed by observations done by a Harvard study that observed tens of thousands of galaxies, that showed those patterns emerging, actually.
Yeah. The whole cosmic web thing is pretty interesting to me. Over 5 years, they managed to confirm the studies of Peebles and Zeldovich.
Yeah,
But I guess Peebles got all the credit for the Nobel
yeah,
Prize.
because he
Oh
got the
well.
Nobel Prize there.
The
Uh,
next half, moving on to the Mayor and Colos. Uh, these two, their work focused more on exoplanets and particularly exoplanets orbiting a solar type star, so one like the sun, because prior to that, the only exoplanets we could see were orbiting pulsars, which is not like a star because they're the size of a large city but extremely dense. So uh, probably not a habitable location for life. That's mainly what we're interested in, these exoplanets.
and and they're highly magnetized, like
Right,
tens of
right.
thousands times more
yeah,
magnetized than the Earth, and the
yeah.
Sun.
Yeah. Joseph, you want to take the next
Yeah,
one?
yeah. So in the 80s, two scientists, Campbell and Latham, both unknowingly discovered exoplanets, um, because they found, they got some signals from their studies of the planets, but they weren't sure what the signals they got actually were from. They didn't know whether they were indeed due to other planets or whether they were due to a brown dwarf, or anything like that. So it was never confirmed, and so they basically discovered them without knowing. So, and like Brandon said, two planets were discovered orbiting a pulsar in 1992, but no planets orbiting a sun-like star were found until Mayor and Fellows in 1995, and they discovered 51 Pegasi b.
So they discovered it using the radial velocity detection technique, which basically they just detected variations and anomalies in how stars and different objects were moving. And then their discovery confirmed the existence of other like planets, which revolutionized planet formation theories, and helped kind of fuel and kick off the search for habitable planets. And now we actually use a bunch of different methods to find exoplanets. So there's radial velocity, there's the transit method, microdensing, um, microlensing, sorry, imaging, timing variations, and orbital brightness modulation. Um, which the main one now is actually the transit method, where we use line of sight to see see patterns of when planets pass in front of stars.
Yeah, I thought that was interesting when Professor Lee like explained that at the end, like how there's kind of like a sinuous curve, and when the planet passes in front of a star, it gets a little dimmer. So that's
Yeah,
how we can kind of detect the period of its orbit.
yeah. I mean,
Um,
I would have
yeah,
expected that people would think to use that first, because it's easier to just say something like you see it versus you have to calculate like radial velocity and like hope that that's
well,
a
I mean,
planet.
I guess that's largely thanks to like the vast improvements in microscopes, and
Yeah,
because they were saying like we'll have 30M class, not microscopes, telescopes,
Telescopes.
uh, but yeah, basically we'll be getting some extremely large telescopes, ELTs,
yeah,
which is a real thing. So yeah, that's cool. And also supercomputers. Something worth mentioning is they talked about the Summit supercomputer from Oak Ridge National Laboratory.
yeah,
And yeah, when that video was made, that was the best supercomputer in the world. But yeah, that's actually been replaced recently by Fugaku in Japan. Um, so yeah, but that one doesn't start operation until 2021. That's something interesting to look into. Maybe that'll be able to detect other exoplanets and stuff even better than Summit.
yeah.
Um,
Which
what
that's
interesting
just
things
gonna.
did you guys learn?
Well, I was gonna like backpack off that really fast.
Okay.
Like it being able to detect the exoplanets and like find them even better than the supercomputers that we have now. That's just an increase like how fast we're finding them, I guess, which I think they said in the video was already like an exponential rate basically. And now we're at over 4,000 plus thousands of candidates that require further observation. So like if you think about how many we've discovered recently and how much that rate is going to be increasing now that we're like getting better and better supercomputers and better telescopes. It's just
Yeah, yeah.
interesting.
That data's from NASA, by the way, for all our
Yeah,
listeners out there. And they found out that the number of exoplanets doubles every 27 months, number of known exoplanets since we
yeah,
started finding them. So the future's bright for exoplanet discovery.
yeah. Which
Nice.
fuels more the idea more of like habitable exoplanets and the idea that like what if there are other living things out there?
Yeah, yeah. It was interesting to see kind of the two different approaches. Like, there's one group of people who studies the origins of life on Earth and compares it to other planets, and then another group of people who's actually trying to more focus on finding the exoplanets directly.
Yeah,
But the way they described it, pretty the closest approximation of life that we know is that they need liquid water, and they need an atmosphere.
yeah,
So similar to that of Earth.
yeah.
Um, and we've
So
apparently, sorry, go ahead.
yeah, so I found a lot of stuff in the cosmology half of the presentation to be really interesting. Like, I don't know if you guys knew this, but I didn't know that the universe was made up of like over 70% dark energy, and then like 23, 20, 24-ish percent dark matter, which I thought was
I
pretty
actually
crazy.
did know that.
Yeah, I did
Yeah,
Yeah,
not.
I'm interested in dark matter and dark energy and stuff. So
yeah,
it's
and so
pretty cool.
I also didn't know that dark matter was collisionless, so I thought that was pretty cool as well. And then
Yeah, yeah. I just knew that we don't really know anything about it. You know.
Yeah,
yeah,
it's like kind of a mystery. Um, but I would want to like look into more of like why it's collisionless, or like how maybe. because that would just be
Yeah.
Yeah.
interesting to
It's
find
like the
out.
only way we can detect it is like its silhouette,
Yeah,
around because it's not observable directly.
yeah,
Yeah. And I also thought it was pretty cool that there's still radiation from the Big Bang just radiating from everywhere in the universe right now, in the cosmic microwave background. I thought
yeah.
that was pretty cool.
Did you guys
I
ever
think
see that video that was like it like described the ends of the universe in detail with like
Yeah, I
coordinates?
have.
I haven't
That was cool.
Yeah,
Oh
it was
yeah, you
kind of
should watch
scary
it.
though. It's like,
really.
yeah,
Yeah, like everything's gonna freeze and all life is gonna end and it's unavoidable, apparently. Yeah.
I mean, yeah, that makes sense. Just because, um, well, like something I was reading something a while ago that was talking about like the expansion of the universe and how like things form basically, um, like at spots where it cools down, and that's where things form. And so like it's inflating at this rate, um, but like things are gonna cool down because it's powered by like energy and energy. And like when it cools down, then it loses the energy and starts forming and becoming matter and mass. I don't know.
Yeah.
But it's loosely related to that, I guess.
I mean, cosmology, pretty much relates to everything in the
Yeah,
universe.
basically.
All right, you guys want to add anything else? Any more thoughts?
I think
Uh,
we're probably running a little bit long, so we should probably wrap it up soon.
Yeah, I'm gonna have to edit this down.
yeah.
Okay. Well, thanks for watching, everyone.
Yeah.
Hope you
Thanks,
found this
everyone.
Thanks,
informative.
guys. Yeah,
And yeah, see you in class Monday.
yeah.